Hello, everyone. Welcome to Blockchain Service Courses. Today, let's talk about the basics of blockchain technology. Blockchain has become a real hot topic recently. But many people still wonder, what is blockchain? How is it implemented? In today's course, I'm going to briefly introduce the fundamentals of blockchain using the well-known cryptocurrency, Bitcoin. First, let's take a look at a simple Bitcoin transaction. Tom wants to transfer $1,000 to Jack. He turns to all the people in his town and yells, "Hi guys. I'm going to use account A to transfer $1,000 to Jack's account B." The townspeople hear Tom. Double check who he is, and then check whether Tom's account has enough money to complete the transaction. If the balance of account is high enough, the townspeople will record that $1,000 will be transferred from account A to account B in their ledgers. For this example, they would record specifically that $1,000 was subtracted from account A's original balance of $3,000, resulting in a final balance of $2,000. They would then record that $1,000 was added to account B's original balance of $2,000, resulting in a final balance of $3,000. The townspeople then go on to announce the transaction to people in other villages. By the end, everyone knows about the transfer and their ledgers all reflect the same account changes. Each of the people involved in this story have their own unique concerns. Jack, who is receiving the transfer, may wonder, could someone tamper with my transaction records? What if his record says he receives $1,000? But other people's records show he only received $100. Other people may wonder, why am I bothering to keep records of transactions that have nothing to do with me? And if we are all recording these transactions, whose ledger is the official one? First, the answer to Jack's question is no. Each block in a blockchain is considered a credit safe. Each individual safe is chained to the next to ensure that the data cannot be tampered with on a wide scale. As for other people's questions, why should they record Tom and Jack's transaction? They will receive minor incentives which are used to ensure the system security in a traditional public blockchain, like the Bitcoin system. Each accounting node receives incentives. In a consortium blockchain, the other people get other hidden benefits instead. In traditional public blockchains, the official ledger is determined through mining to ensure data consistency. For example, when Tom announces his transaction, the people hearing this announcement will have to answer a question from the village question library. Anyone who answers the question correctly is recognized as having an official record and will receive an incentive or reward. In contrast, a consortium blockchain uses consensus mechanisms, such as fast Byzantine fault tolerance and Kafka algorithms, which are like voting, to ensure that all records are the same. This whole story illustrates the basic way blockchain works. Blockchain is not some brand new, innovative technology. In fact, it is just a really smart way of combining several existing technologies, such as the hash algorithm, digital signatures, P2P networks, and consensus algorithms. These technologies enable automation of credit systems, value transfers, and contracting through efficient collaboration. Blockchain is an extremely effective technique to build trust and improve collaboration efficiency. Blockchain, like its name implies, can be visualized as a chain of blocks. This figure here illustrates this. The pink section is called the block header. It records the block's version number, the hash of the previous block, and the timestamp of the Merkle root node. A new block then stores the hash of the previous block, allowing them to be linked together. This ensures the data cannot be tampered with. Now, let's look at how current blockchain technology was developed. Satoshi Nakamoto established the first Bitcoin system in 2009. Since then, Blockchain has evolved into three standalone forms: Bitcoin, Ethereum, and then Hyperledger. Bitcoin and Ethereum mainly focus on public blockchain technologies, while Hyperledger focuses on enterprise-grade consortium blockchains. Today, Ethereum is also gradually providing enterprise-grade consortium blockchain applications. Bitcoin and Ethereum prove consensus through computing algorithms such as proof of work, POW, and proof of stake, POS. Hyperledger, on the other hand, provides pluggable consensus, like the fast Byzantine fault tolerance and the Raft algorithms. For smart contracts, Bitcoin's simple script engine means it is not Turing complete. Ethereum and Hyperledger, though, provide complete operating environment for smart contracts. The contracts can ensure that transactions are carried out in an orderly manner. Ethereum supports Solidity, and smart contracts can run in the Ethereum Virtual Machine, EVM. Hyperledger supports mainstream programming languages like Go, Java, and Node.js. These languages enable smart contracts to run in Docker containers. These are the main differences between the three mainstream blockchain technologies. Now, let's take a look at how hashing and signature mechanisms are used in a blockchain. Each block in a chain can record one or more transactions. Hashes are generated for transactions and form a Merkle tree. The root node of the Merkle tree is recorded in the block header. After a block is submitted, a new block records the hash of the previous block. This mechanism ensures that the previous block's records cannot be tampered with. A signature is used when a transaction occurs. Each party involved in a transaction holds a public and private key pair. The transaction initiator uses their private key to create a signature. After receiving the transaction, the other party uses the public key to verify the signature. This process ensures the integrity and verifiability of transactions. Now, what is a smart contract? It is also called a chain code. A smart contract can be regarded as a state machine when preset criteria and rules are met. A smart contract is triggered and executed. The ultimate goal of smart contract execution is to generate ledger data in blocks. Let's take a game between Real Madrid and Bayern Munich as an example. I bet John that Real Madrid will win that match. If I won, John would give me $1,000. If Bayern Munich won, I would give John $1,000. This was the rule of our contract. The smart contract was then triggered by the conclusion of the game when the winner was announced. Since Real Madrid won the game, John gave me $1,000. This is how a smart contract works, based on rules and events. Finally, let's talk about the consensus algorithms. Consensus is the key technology that powers blockchain. As mentioned before, POW is the consensus algorithm used by Bitcoin. For POW, everyone is issued the same challenge question, and anyone who successfully answers the question is considered to have the standard ledger. This ledger is then used as reference for the others. The main consensus algorithms used in Hyperledger include Byzantine fault tolerance and Kafka algorithms. These algorithms work more like a voting mechanism. In addition, a proof-of-work algorithm can also be used as a consensus mechanism. Of course, no matter which algorithm is used, the final goal is to ensure that the data of each accounting node on the chain is consistent. That's all for this course. Thank you for watching.